Okay. In this lecture, I wish to clarify some of the elementary aspects of my theory of grand unified physics without going into a lot of the quantum gravity and quantum mechanics involved. Let's just go over some of the combinatorics. The universe is essentially 91 simultaneous equations written as 36 statements, 91 being 1 plus 2 plus 3 plus 4 plus 6 plus 12 plus 18 plus 36, being that sum. It is basically a ladder, a staircase full of the factors of roughly one half of the factors of 36. 36 being the duplicate or square of 6, a perfect number. 1 plus 2 plus 3, 1 times 2 times 3. I don't want to get too deep into what I mean by duplicates, but let's look at the equations. Each of the 36 statements is essentially something like, one of them would be, for example, nothing exists. Or, wait a minute, nothing can exist. Or no, wait, that's not what it says. It says nothing is impossible. Another one of the statements is nothing is impossible. So you have both those statements. And you see what's kind of unique about those things. The more you think about it, each one of those statements like that has 6 different definitions. For instance, to begin with, nothing is possible. I mean, that is the state that it means two things. It means that no such real thing is possible, meaning that nothing exists. It also means that absolute nothing is something that cancels does exist. So it has two interpretations. The more you work around with the logic, you see that it is actually 6 statements, meaning that the universe might actually be a little bit more complex than 36 compound statements. It might just be 6 compound statements, but I believe it's 36 of them. 36 times 6, I don't know what that is. I think it's 216. That's in the richness of the universe, or 91. It's defined by 6 or 7 different numbers, 7 being the transcendental number past 6. The universe is essentially 6 disciplines: physics, math, logic, philosophy, psychology, biology, and maybe included in logic also computer science. And the 7th discipline is theology. Theology is really outside the bounds of physics, so it's listed as a 7th possibility, like an afterlife or something. But the 6 definitions act coherently, congruently, like amongst themselves in the 6 by 6 different statements that constitute the rules of the universe. They're thematically arranged. The products of 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, 9 times 4, 12 times 3, 18 times 2, and 36 times 1. Those are a symmetric ladder. So different factors of 36. The way the equations are derived is they're just logical variants of a single rule applied to it. Logical constraints, statements about everything, nothing, existence, and non-existence, and 2 more things, such as minima and maxima, for example. So it's kind of like first you negate it, then you add the affirmative, then you add a qualifier. So that's how you build the 36 statements. And indeed, there are 6 math statements, 6 physics statements, 6 philosophy statements, 6 biology statements, 6 psychology statements, and 6 logic computer science statements. And if you break it down into 2s and 18s, you'll find that there are compounds that exist that it's a little bit elaborate. I don't want to get too much into that kind of thing, but it kind of unfolds in a multiple way. So that each thing has 6 or 7 symmetries, relates to things, and has 6 interpretations. And 7 being transcendental. Everything is defined in terms of 7s because it's transcendental. I don't mean like E. I just mean it's a number beyond the bounds of any physical force measurement. Like, for instance, the strong force is only R to the 6th. And the others are all lower. So just R to the 6th, that's as high as it goes. So symmetry beyond that doesn't exist. So you say that these are the number of symmetries that exist. Everything is defined in 6 ways. I don't want to get too much into that, but it's kind of complex. You kind of wonder how I came across these equations. It's built into something called the Karkamar equation, which is basically an equation for the angular momentum of the universe, angular momentum being quantized. Basically, the way you derive this is basically you say that the node of the universe is like a vibrating string. The nodes are the quantized angular momentum. And everywhere that's not nodal in the vibrating string is when one of the rules is broken. Any one of the 36 or 91 or 216 rules is broken. Leads to such an asymmetry that nothing can exist outside of the nodes. What happens at the nodes is very special. The nodes, the string model that is the universe, not superstring, but like string, like nodes and static points and maxima, peaks and stuff, are essentially the point where every element of mass in the universe has angular momentum. Well, that's constantly rotating at an increasing or decreasing speed at a quantum level. It may be even decreasing hyperbolically or exponentially or something, but it's getting finer and finer. When it first started out, it was spinning infinitely fast, but it's getting finer and finer. It just gets smaller and smaller, the quanta. What this means is it forces more quantum mechanics. Eventually, everything will end up in black holes. But, I mean, that's just the way the universe works. I don't want to get into how my proof of this. It's fairly ingenious. It's 209 steps long. It's about as long as Weyl's proof of Fermat's theorem. Basically, I begin with the universe as an aggregate model, defining it as a non-integratable whole, defining as an integrated whole at the same time, defining as non-existent in any definable way, any subcategory being inherently quantum mechanically more influential than the whole, any supercategory being equal to the whole because the universe is never larger than itself, and that just went about 209 steps. I was able to derive that angular momentum is quantized. It's fairly elaborate. I don't really remember all the steps, but it's genius. Anyways, then the Karkamar equations relate K, the absolute angular momentum in one coordinate as resolved, was the only coordinate, as three products, Ka, Kb, Kc, meaning that there's three components to the angular momentum times three spinors, 2x2 matrices. The 2x2 matrices are composed of constants in each particular matrix. For each one of the 36 equations, there are 36 Karkamar equations per particle, meaning that there are 36 spin variables, meaning that there's also, I don't know what 12 times 36 is, but it's a fairly large number. That's the number of I think it's the number of particles in the universe, but also it's the number of these constants. They're basically variants of 1, minus 1, I, root, square, E, pi, gamma, Feigenbaum's number, and 0 and infinity or something. There's only like 12 or 8 of them. I think there's 12, but it might be 8 too. I think it's 8 actually. And the way it works is in the Karkamar equation is these constants of variability are in fact like they're symmetric in a highly way. They're just cyclic permutations of each other. So the symbols rotate out. The neat thing about functional analysis is when you have a root, you have to take a function. This essentially defines the difference between a particle and a wave, like a photon and a particle. It's my integration with string theory. It's not defined as a closed or open string, heterotic string. It's defined in terms of a spinor, not a Dirac spinor. A spinor whose terms leave a functional or a scalar map, meaning you have to take root of something, square root of something at the last term, and you have to take a function or corollary is just a constant, like I, square root of I or something. Then it's just a photon, for example. I don't want to get too much into what my advanced theory of particulates demands. Demands that in the non-node parts of the wave equation, the universe, that massive particles become photons and photons become massive particles. And it basically means that everything cancels out anyway, even when one of the rules is broken. That's the asymmetry breaking in the universe is one of the 216 or 12 times 36 or whatever, 216 times 12 equations is violated, and you get a total asymmetry and everything cancels. So it's kind of unique because the Karkamar equation generate the angular momentum is quantized at the nodes but doesn't exist at the non-nodes, but still it has enough gravitational influence to flatten out space just about everywhere except where there's mass or photons, meaning that the nodes are in a sense critical. What I mean to say next is kind of unique. It forms a ring. The ring is composed of, I believe, 91 gluons in a harmonic progressive series, like 1 over 2, 1 over 3, 1 over 4. For example, in a harmonic sequence around a ring. That's all the universe is fundamentally. You may ask why the universe has multiple definitions, such as 36 equations, 91 equations, 216 equations, or actually for each different number, it's a different idea. Like the 36 things are just statements. The equations are actually 91. 216 refers to the number of scalars involved, and stuff like that. It exists in multiple ways. I guess the important thing you'd say is that no two states exist at the same time. You don't have you only have one of seven or 6 of 7 existing at any particular time. It might be 1 of 7, but I believe it's 6 of 7. Meaning there's always some part of indeterminacy within it, meaning that it allows for the existence of matter because it's indeterminate, meaning that you don't know how much is there, and therefore it might as well be 0. And when you take all the forces into effect, it does indeed cancel to 0. For a long time, physicists considered the universe as a quantum vacuum fluctuation. I would estimate that it might be correct, but I'd rather tend to think it's absolutely nothing anyway at all times. But that's just my intuition. Also, it's been stated that the gravitational potential energy, tensile energy of the curvature of free space exactly cancels the relativistic either the rest mass or moving mass of the particles creating the torsional field. That might indeed be true. It's really kind of trivial. I wouldn't worry about things like that. Anyway, the Karkamar equations define the angular momentum in some way. The way it's changing, or the way it forces things, or the rate of change, or something, the way it's rotating, the quantum effects. It may actually be that the Karkamar constant K is in fact just one universal constant or rate of change for as the universe evolves time-wise, as eventually everything turns into black holes, because everything slows, the angular momentum slows down. The free angular momentum, what does I mean? Angular momentum is both quantized and unquantized, meaning that although angular momentum can assume any number variable, like continuously, it also is increasing or decreasing by a constant scale, or each particle in the universe increases or decreases like a giant clock. As you add in or multiply out a different angular momentum term. In that sense, you could say that everything is slowing down, for example. It might actually relate to a fascinating result in the universe. If everything is slowing down time-wise, like spinning less slowly, eventually you'll have either a black hole, everything will fly apart, or everything will just evaporate. Or, like Penrose has often said, the radiative mass will radiate into photons, and once there's no mass, time doesn't exist, and so you just have a black hole. Or he also suggested that the Penrose universe is in a nodal string, his own nodal string, from black hole to black hole. Just they admit a velocity and force term, maybe in higher order terms, but the sense position is always 0, meaning that from one universe to the next, you can have particles traveling through, but it's always, the mass is always 0 at the nodes, the Big Bang. Just the particles can obtain momentum and pass through from one universe to the next. I think that's a bit grandiose. I think there are only 2 universes that are connected back and back to each other by black holes. One of them collapses, the other one expands to ever further till it evaporates, or what Penrose calls conformal evaporation, in which the angles are lost and you just have a black hole again, because everything can be seen as arbitrarily distant from each other or arbitrarily close, which under the rules of quantum mechanics means that it doesn't exist. That's pretty much all I have to say about the Karkamar equations. They are highly symmetric, What I mean by a cyclic permutation is like the first one would be IJK, the second one would be JKI, and the third one would be KIJ. It's like permutations of the 8 or 12 symbols. I do believe Feigenbaum's number and pi and E and gamma or some of those numbers. There's other numbers. In physics, I like to think E, 2, -1, maybe 12 are physics numbers. Math numbers are like -1, maybe not I, but pi and a few other numbers, like gamma, for instance. That's the way I like to think, as each one of the 6 disciplines of the universe is composed of has qualities. Math is 0, physics is imaginary, philosophy is negative, and biology, psychology, and logic are other terms. I forgot what those 3 I defined them as. Biology, I think, is 2, psychology is 3, and logic is 3, and psychology is 5, I think. But anyways, those are the fundamental constants and constraints of my theory of the universe. If you really sit down and work out the math and work out the principles involved, you'll find that it very nearly accounts for everything as nothing at all times, and with change taking place, accounting for instance, nothing is impossible and nothing is possible at the same time. Basically generates quantum mechanics. We also say that any two things infinitely far apart from each other are infinitely close, like it's scale free. That generates general relativity, and like force the other forces through the equations. And there might only be 6 equations or statements. I believe there are 36, though I have strong intuition that it has to be a perfect number, 6 squared duplicated. The essence being that the duplicate x squared, as I've explained in another lecture, is essentially delta x, an infinitesimal, meaning the universe is very nearly nothing except a thought, the simple thought that it exists simply because it must, it can, it does, and it will, because it is possible. Therefore, it does exist because it's psychologically plausible. That's what I mean by psychology playing a role in physics. By biology, meaning it has to generate life as a fractal to generate psychology that makes it tenable, meaning that psychology is superior to biology. Likewise, physics is superior to math, and philosophy is superior to logic. And philosophy being superior to logic means that aesthetics is more important than something making sense. Likewise, physics being more important than math, meaning that something is real is more important than something being theoretically plausible. And that's pretty much all I have to say in this lecture. I just wanted to clarify some of my principles of grand unified physics in a combinatorial sense. The actual math and spinners and integration of mathematics and physics ideas, it's fairly elaborate. I wouldn't say it's impossible. I would definitely say you need doctoral in physics and maybe math too, and quantum gravity, postdoctoral experience to really understand my ideas. And that being said, I'd just like to conclude this lecture with, hopefully I'll have a grand unified theory of physics within a year or two. I got to kind of hash out the Karkamar constants. They appear to be fairly well behaved. They're just, in some strange way, they're just permutations of each other. I haven't really had enough combinatorics and permutations to understand how you constructively vary 8 or 12 different variables. But there must be a way. I'll think of it sometime. Additionally, you might also construe that some of the constants might be the fundamental constants of nature, like the gravitational constant, the Feynman constant, the charge constant, the Compton constants, the Rydberg constant, the 11 different constants in nature. You wonder why there's 11 of them, not 12, since I seem to stress that one of the symmetries of the universe is 12. 11 being incomplete, meaning that quantum mechanically there's a 13th variable, which negates 11 constants to generate 12 terms averaged, which essentially mean nothing, 12 being the duplicate of a perfect number. Also, I'd like to say with respect to symmetries like 12 times 3 and 9 times 4 and so forth, the symmetries in each one of those is that in 2s and 18s it's opposites, in 3s and 12s it's triplicates, in 4s and 9s it's Aristotelian logic, and 6s it's duplicates of nothing, and so forth for the other laws. It's a little bit counterintuitive what the difference between 4 and 9 and 9 and 4 is. It's a quantum opposite, meaning that although the terms are reversed, it's symmetric anyway. In this way, I would hope you'd be able to evolve the logical constraints which control the universe from these symmetry principles. You see what the fundamental ideas of my universe are: essentially nothing, canceling, symmetry, perfect numbers, and staircase ladders, like number sequences, and things like minima and 6 disciplines and stuff, like a few ideas and a few statements about the universe which generated as a whole. I would generally tend to think the universe is just a 3-dimensional fractal, but I could be wrong. It might be something else, but I would tend to assume it's just an example of a plausible 3-dimensional fractal. Or you might think about it, the idea of the Mandelbrot fractal is so simple in 2 dimensions, you wonder why it can't be generated in 3. The answer is because in 3 dimensions, x and y and z and x commute simultaneously, meaning that if you try to take the difference between the two terms, it cancels to nothing. Therefore, it's not stable, and you get an empty field for your convergence. That's pretty much all I have to say about this lecture. I just wanted to clarify some of the combinatorial principles and how to generate the Karkamar equations. We've got a spinner. The spinner coordinates is basically the coupling forces between each one of the two forces, strong and weak, weak and gravitational, electroweak and gravitational, like the coupling terms, written in terms of two particles. The symmetry, that doesn't mean they're all skew symmetric or anti-skew symmetric. By symmetry, it means that they exert a planar force, which is fluid dynamically convergent in 6 dimensions as opposed to 9, which again leads to 6 by 6s and tensors. A 36-dimensional tensile equation is essentially nothing under the duplicate of a perfect number. The duplicate of something perfect is nothing. In duplicates, that is perfect, because you take something perfect to duplicate perfect, which is nothing, back to another duplicate of that, which is perfect again. The universe is in angular momentum oscillating between nodes and heights, peaks, between perfect and imperfect, between real and unreal, when one of the rules is broken, when they're all confluent. Oddly enough, the silent time is important here. You can't have the universe without the peaks and troughs. It has a strange sort of symmetry. The universe is essentially symmetry breaking in rings also. It's another thing I wish to suggest, that the Mobius strip and the ring that it represents in the Riemann signature being time mapped across 2 Mobius strips in a ring, as I mentioned in another lecture, is essentially a very simple model for taking the duplicate of a Mobius strip to equal a ring, taking the duplicate of a ring to equal a Mobius strip. The 3 form a cyclic variable over 6s. You get 3 Mobius strips to 3 rings. It cancels to 3 platonic formed, 3 third-order platonic rings, which are both logically possible and impossible, henceforth impossible. So nothing exists. That's basically the essence of my theory, at least in physics. It's more profound than that because nothing exists in math. Physics is imaginary. That's how I like to constrain that anything that really is physics will always have imaginary constants in one side of the equation. Anything that's math will have 0 as an equation. That is what I like to stress, that energy, momentum, and angular momentum are really just math. It's not physics. But physics plays a role too, so there's other laws like Newton's law of gravitation, the Coulomb's law of attraction, and things like that. That's basically how my theory works. It's not that hard, and hopefully it'll gain ground with certain people when I present it before them.